All right, you have some graphs to begin working with here. We're going to stick a little bit in these couple of days before spring break to play with a little bit. So the first thing we need to do is just review what's expected of graphs. So the side that says rules, tables, and graphs. Use the graph below, find the x and y coordinates. A couple of things to notice here. It tells you this is the x coordinate. So the ones that go left to right are the x's. Where are the y coordinates? Can you see it? The y's are up and down. We've talked about this a few times as we made line graphs with science. But your y coordinates go up and down. If you want to think of Miss Yoder and how short she is, that might help you remember that the y is up and down. Another thing that you can use to help you when you're thinking of x's and y's, x comes before y in the alphabet. You always graph the number over first and then the distance up. So x coordinates always come before y's. Okay, so it says, find the x and y coordinates for each point shown. They already gave you part ways down over 2 and up 3. But they want you to get 2 points before that. Well, here there are 3 points, and here there are 2 points. If they only give you room for 2 blanks, it makes sense to say, well, it must want the 2 coordinates that are on this side of the 2, 3 that it gives. So then you have to decide, okay, how am I going to do those? I like to start at the beginning. So how far do I have to go over to get to this point? Well, jeepers, I haven't gone over 1 even. It's exactly on the y-axis. That means for the x, I have 0. Now for the y, how high do I get to go up? It's right beside the number. The y coordinate is 5. What about this next one? Well, here it has gone over 1. So my x coordinate is going to be 1. What about the y coordinate? Well, the y is how high it goes up. You always find over first, then up. How high has this one gone up? You go over and see that it has gone up 4 lines. You should be able to figure out how far, oopsies, come on, give me blue. You should be able to figure out how far over, well, they already did that one, so how far over this coordinate is. And then you should be able to figure out how high it goes on the y-axis. So this coordinate, how high did it go on the y-axis? Those 2 numbers go in these blanks, and so on for the last 2. That's pretty self-explanatory. Then we get to this bit of information. Eli is 10 years old and can run an average of 5 yards per second. His sister Sarah is 7 and can run an average of 4 yards per second. Okay, so there's a lot of reading that goes along with this, but there's going to be an important bit of information right here. They have a 60-yard race. Eli is 5 yards a second. Sarah is, we'll make Sarah pink. Sarah goes at 4 yards in each second. The race itself, the whole race, is going to be 60 yards. And because Sarah is younger, Eli gives her a 10-yard head start. That bit is shown right here. Sarah goes 10 yards before the race even begins. So Sarah's first distance is 10. She then goes 4 yards every second. So by the second number 1, she has gone 4 yards, but it's 4 more yards than the 10 where she started. So you have to have 4 yards added each time Sarah goes another second. So 10 plus 4, that's 14. Okay, here we have another second. So Sarah should have gone 4 more yards. Did she? Well, 14 plus 4, yes, it gives you 18. Here she goes another second. Each box is 1 second more. So for Sarah, you should add 4 yards for each second that she runs. So each time you go down to a new box, it has been 1 more second, so she adds on 4 more yards. It's nice, partway through they give you this 38 to check and see if you're doing things right. My suggestion would be to get all of the distances for Sarah and then come back and get all the distances for Eli. Why? Well, Eli goes a different distance in each second. For 1 second, Eli is going to go 5 yards. So, at the beginning, Eli's at 0, but then 5 more yards. He has gone 5 yards in the first second. By the second second, he goes 5 more yards. So he will have gone 10 yards total. He's gone 15 yards in the third second. So I would fill in all of Eli's times after all of Sarah's are in. Then it wants you to look at the table and answer these questions. Who wins the race? This is where the idea of how long the race is comes in. The race is 60 yards. So whoever gets to 60, let's say 38 plus 4 is 60. And let's say when I've added all these 5s at 11, it comes out to be 60. By the way, both of these are wrong. But for the sake of argument, let's say this is where the 60s come out. So who won the race? Well, it'd be the first person that got to 60. So according to my numbers that are wrong, Sarah won the race. Her winning time is 8 seconds. So that's how you would answer these 2 questions. Finally, it asks, who is in the lead during most of the race? How do you know they're in the lead? Well, they've gone farther. So here, Sarah's in the lead. Sarah has still gone farther. Sarah has still gone farther. So you need to look all the way down as you look at these 2 distances. Who has gone farther? That's the person who was in the lead during most of the race. So you need to finish those, and then this chart still becomes important over on this side. If you want to make it easier, what I might do is I might copy down time and Eli on a separate piece of paper. That way I don't have to keep flipping it over. Why? Well, it wants you to graph the results. So you will need 2 colors. One color is Eli, one color is Sarah. We know at the beginning Eli is at 0 and Sarah is at 10. How does that look? Well, I was using pink for Sarah. So Sarah was 10 yards at the beginning. I just flipped it over, although the camera has it frozen here. Sarah was at 10 yards at the beginning. So I would make a beautiful big old dot at 10 yards for Sarah. Then, after 1 second, so here it shows 1 second, Sarah has gone 4 meters. So my dot for Sarah is not quite up at 15, it's just a little bit below. So then I'm going to connect those 2 dots with a straight line. Sarah's next distance at 2 yards is 18 meters. So I'm going to put her dot for 18 and connect those dots. Meanwhile, what does Eli's distance look like? Well, Eli started at 0. Then he went 5 meters. Then he went 10 meters. Then he went 15 meters. What have I forgotten to do? I forgot to connect my dots. It's easier if you connect them one at a time to come out with a straight line. So all of the distances that are over here in this chart need to get shown in this graph. Finally, you have a few more questions. You can use the graph to answer the questions, or you can use the chart. The chart might be a little bit easier because the question was, how far apart are Eli and Sarah at 7 seconds? It's easier to use the numbers and say, how far apart are the numbers, I don't know, 10 and 38? Oh, well, they're 28 yards apart. So you would subtract these 2 numbers. Suppose Eli and Sarah had to race for 75 instead of 60 yards. So this graph, see how it allows you to extend it out to 70? If I think about Eli was increasing by 5 each second. So it would be really easy. There we go. It would be really easy, although I'm probably not going to do a very good job, to extend this line for Eli past the 60 yards, which is right there, but keep on going in his same rate of speed up till 75 yards. I would need to do something similar for Sarah, and that would help me to explain who I expected to win, and it would also let me say, oh wait, I've got to 75 yards. Gee, how long did that take? How many seconds was it when I got to 75 yards? And how far ahead would the winner be at the finish line? In other words, how many yards behind would the other person be? So these get a little bit trickier if you want to use the graph to answer them, or if you want to go back on this chart and then just keep on going up by 5 for Eli, up by 4 for Sarah, and 1 second increments. Either way, it should help you come up with that answer. So this is your graded assignment. Finish up as I have asked you to do so, please and thank you. Send me the photograph of both sides of the paper.